This one is a different type of indeterminate form. So we've had 0 over 0, we've had infinity over infinity. Now we have infinity minus infinity. And this one's a little bit tricky because we don't know which infinity is bigger. Infinity is not a number, it's just an idea. It's an unbounded quantity. So we don't know if this unbounded quantity is bigger than this unbounded quantity. So in this case here, when we plug in 1 for x, we get 1 over 0 on the first one, which means that fraction is going to go to infinity. We get 1 over 0 on this one, and so we end up with infinity minus infinity. We don't know how big those infinities are, so we're going to have to rewrite it. So what do we do to rewrite this in a form that we can do that? Yeah, we combine them. We get a common denominator and write them as a single fraction. So we're not using L'Hopital's rule right now. And that's an important thing to understand. The indeterminate form infinity minus infinity does not work with L'Hopital's rule. But usually when we have infinity minus infinity, we can rewrite it in a way that does. So if I try putting 1 in now, that the numerator is going to go to 0 and the denominator is going to go to 0. And you can take a second to confirm that if you want. But now we have an indeterminate form that does work with L'Hopital's rule. Now we have 0 over 0. And so with 0 over 0, what we can do is take the derivative of the top and the derivative of the bottom. What is the derivative of x minus 1 minus natural log of x? 1 minus 1 over x. Good. What is the derivative of x minus 1 times the natural log of x? What are we going to have to use for that derivative? The product rule. So we take the derivative of the first times the second plus the first times the derivative of the second. And when I do that, and you can take some time on your own to confirm that if you want, but when I do that, I don't like this fraction right here, so I'm going to rewrite it. Instead of x minus 1 over x, I'm going to write it as 1 minus 1 over x, like that. Now if I try putting 1 in, on top I get 0, on bottom I get 0. So does that mean it's time to give up? Sure. Or we could use L'Hopital's rule. Good, Alyssa. So we do the same thing. We take the derivative again. So this is negative x to the negative 1. So the derivative of that is going to be 1 over x squared. On the bottom, we would get 1 over x plus 1 over x squared. And now we can plug in 1. And we would get 1 over 1 over 1 plus 1. I'm sorry, 1 over 1 plus 1, which is going to give us 1/2. So in this particular case, this infinity is 1/2 bigger than this infinity. It's kind of crazy to think about, isn't it?